Hi guys, so in this video I'm going to be showing you some more multiplication of matrices, except these matrices might have different order or different dimensions. So the order, I think I mentioned it in the previous video before when we had 2 by 2 matrices. You're counting the rows and the columns. So this one here, because there's 1 row and 2 columns, we would call this a 1 by 2 matrix. Okay, this one here has 2 rows and 1 column, so we would call this a 2 by 1 matrix. In this one, we've got 2 rows and 1 column, just like this one, so it's the same as up here, and likewise, that would be a 1 by 2. Now, this one down here, there is 1 row and 1, 2, 3 columns, so that would be a 1 by 3 matrix. And this one has 2 rows and 1 column, just like the ones from earlier, so it's a 2 by 1 matrix. So it's a good idea to bear this in mind, okay, because these also tell us whether the 2 matrices are compatible. That means whether we are able to multiply them together, because it's not always the case, as you'll see later on. But we'll talk about that at the end. To start with, I just want to multiply these matrices together. So remember in my previous video, I advised you to draw rows around the first matrix and columns around the next. And you're multiplying from left to right and from top to bottom before you write down the answer over here in your other matrix. So let's have a go at multiplying. Remember, we're going from left to right, top to bottom. So we're doing 1 times minus 2, and then you're adding and you're multiplying these two together. So 2 times 3. So in this matrix, there is in fact only just one number. Okay, so 1 times minus 2 is minus 2, 2 times 3 is 6, so the answer is just 4. So this is to be expected, because if you look at the order and examine carefully before you multiply, see there's the number 1 here and the number 1 here. These two numbers on the outside tell us the order of the answer matrix. So because it's a 1 by 1, we expect a 1 by 1 in our answer, which is this type of matrix here. Okay, so in the next one, remember, you take the numbers that are on the outside in order to work out what type of matrix it's going to be at the end. So on this one, it's going to be a 2 by 2 matrix in our answer. Okay, so you know already roughly what type of shape it's going to be at the end. So let's have a go at multiplying. Draw the rows and then the columns, and let's multiply. So remember, you only write something down when you get to the end of the row and the bottom of a column. So on this one, we get an answer straight away because we're doing 4 multiplied by minus 2, and then that's it. So that one is the top left element. So for the top right, I'm using the top row and the right column, and I'm just multiplying these together. So 4 multiplied by 0 is just 0. So for the bottom left, we use the bottom and the left, and we multiply these two together. So 5 multiplied by minus 2, which is minus 10. And the last one, you can probably guess, it's going to be 5 times 0, which is 0. Okay, so those ones are actually very quick and easy compared to when we multiplied the 2 by 2 matrices together. All right, now let's look at the last one. So I'm going to have a go at multiplying. I'm going to draw a row around this one and a column around this one. So I'm thinking it's going to be a 1 by 1 matrix. Let's see. So minus 3 times 1 plus 4 times 2 plus 5 times, and I've run out of numbers. So there is no number to multiply the 5 with. So we say these matrices here, they're not compatible. It's not possible to multiply these two together. So I can't do this one. I'm just going to leave that one. I can't multiply them. So just something else I'll point out here. Notice how in these two matrices here, these two numbers are the same. In the second question, these two numbers are the same. But in the last one, these numbers are not the same. So whenever those numbers are different, so if you get good at working out the order and you know how to write that down at the beginning of your question, whenever those numbers are different, you know the matrices are not compatible. You won't be able to multiply them. So just remember what that number actually meant. That number there that's rows, remember? And that's columns. So the number of columns in the first matrix must be different to the number of rows in the second one for them to be not compatible, okay? So, or otherwise you can just have a go at multiplying and see that the numbers run out just like I did there. So, okay, so in the last question, I'll be multiplying two 3x3 matrices. So remember, it's a 3x3 because there are 3 rows and 3 columns, and the same with this one. So I can expect my answer to also be a 3x3 matrix. So on this one, I'm not going to write down all of my working out because it's going to take forever. So I'm just going to talk you through the calculations and we're going to write down our answer over here. So for the top left element, remember to use the top row and the left column, and you're multiplying from left to right and from top to bottom, and you only write down the final element, the final number, when you get to the end here and here. So for the first one, 3 times minus 1, which is minus 3, plus minus 1 times 3, which is also minus 3, plus 0 times 2, which is 0, well, minus 3 plus minus 3 is just going to give me negative 6. Okay, so that's the first one. Now for the top middle element. So I'm using the top row and the middle column. So I've got 3 times 0, which is just 0, so I won't worry about that one. Minus 1 times minus 5, which is positive 5. And 0 times 1, so again, that last one's just 0. So the only one that counted there were those two, which was positive 5. Okay, now for the top right. So we're using the top row and the right column. So this time I've got 3 multiplied by 2, which is 6, plus minus 1 times 6, which is minus 6, plus 0 times 4, which is just 0. So I've just got the 6 minus 6, which is 0. Okay, so you can show a little bit of working out like me, but you don't need to write out all of, like I did in the previous examples, like all of that, because that will take you a really long time and you don't want to run out of time if you're in an exam. Okay, now for the middle left number, so the middle row and the left column. So we've got 2 times minus 1, which is minus 2, plus 4 times 3, which is positive 12, and 1 times 2, which is 2. Okay, so if I simplify that, it gives me 12. Okay, notice how I keep my finger there as well. That's a good idea because when you're multiplying, if you take your finger away mid-multiplication, sometimes you forget which one you're up to. So that's another little bit of advice for when you're multiplying these really big matrices. So let's have a go at the middle one. So we're doing the middle row and the middle column. So I've got 2 times 0, which is just 0, 4 times minus 5, which gives me minus 20, and then the last one, 1 times 1, which gives me 1. So that simplifies to negative 19. Now for the middle right. So these two, the middle and the right. So I've got 2 times 2, which is 4. Then I've got 4 times 6, which is 24. And then finally 1 times 4, which is 4. Okay, so 24 plus 4 is 28, so that gives me 32 altogether. Now for the bottom left. So the bottom row and the left column. So minus 2 times minus 1. Remember, a minus times a minus is a positive. Gives me 2. Then 3 times 3, which is 9. And lastly, 5 times 2, which is 10. So 11 plus 10 is 21. Nearly done. Okay, so the bottom middle. So we've got the bottom row and the middle column. So minus 2 times 0, well that's just 0. 3 times minus 5 is minus 15. And 5 times 1, which is 5. So that simplifies to negative 10. And the last one, so the bottom right, so I'm using the bottom and the right. Minus 2 times 2, which is minus 4. 3 times 6, which is 18, and the last one, 5 times 4, which is 20, so that's 38 minus 4, which is 34. Okay, so that's pretty long. I hope you don't get many of those, okay, because they take forever, and I hope now you understand multiplying matrices a bit more than before.